This is a quick overview of how to balance chemical equations. I'm going to allow you to refer to your own periodic table so that I don't have to keep going back and forth to that, but here we go. So the three steps in writing chemical equations, the three steps are: write your symbols down, that was number one. Number two, get your formulas correct. And number three, you balance. To write formulas correctly, you're going to use charge and subscripts. And to balance, you're going to use coefficients only. Okay, so the first one here, you got zinc, symbol Zn, plus aluminum chloride, Al with Cl. Yields is an arrow. Zinc chloride, zinc chloride, that's a Cl right there, plus aluminum. Okay, we've done our step one. Now step two. Now step two. We need to write our formulas using charges and subscripts. So zinc is by itself, has zero charge. You only have to worry about charge there. Don't worry about charge. Aluminum, though, is plus 3 because it's in a compound. Chlorine's minus 1. These charges can be found on your periodic table. Zinc over here is in a compound, so it's plus 2. Chlorine's minus 1. And aluminum over here is by itself, so it's 0. To write the formulas correctly, we're good there. That's a 3, that's a 1, so you're going to need to put a 3 down at the bottom there. So we'll put a 3 right there. And the zinc is 2 and the chlorine is 1, so we're going to need to put a 2 down here. Somehow I lost my 3 there. And the aluminum is 0, so we don't need to worry about it at all, so we just leave it alone. So now we've done formulas where we do charge and subscript. So we use charge and subscript to write our formulas correctly. Balance, we're using coefficients. We look on this side, there are 3 atoms of chlorine. On this side, there are 2 atoms of chlorine. We need a common multiple of 3 and 2. What is the common multiple? Hopefully you're thinking 6. So I need to put a 3 in front of the whole compound to give me 3 times 2, not adding, times 2 to make 6. Over here, you put a 2 in front of the whole compound. 2 times 3 makes 6. So on this side, there's 6 atoms of chlorine, and on this side, there are 6 atoms of chlorine. When I put that 2 there, there was also a side effect of making 2 aluminums. So I have to put a 2 in front of the aluminum on this side. And when I put the 3 over here, I had a side effect of making a 3 zincs. So over here, I need to account for that by putting a 3 in front of the zinc. So I'm going to put a 3 right there. All right, next question. We got aluminum nitrate, so our symbol, Al, and nitrate is at the bottom of the periodic table. It is NO3 plus sodium hydroxide, Na. Hydroxide is one of the polyatomic ions that ends in IDE. Remember, there are only like 3 of those, cyanide, hydroxide, and peroxide, but that IDE usually means a single element, but for hydroxide, it is a polyatomic ion. Yields, sodium and nitrate, NaNO3, plus aluminum and hydroxide. So they're just changing partners like in our lab that we worked on. So the aluminum went where the Na was, and the Na went where the aluminum was. All right, now we need to look at step 1, get the symbols down. So if you look up here, we do the symbols first. All right, so now we're going to write the formulas using charges. So aluminum is plus 3. Nitrates minus 1, so I'm going to have 3 of the nitrates, which requires a parentheses and a 3 outside. Sodium's plus 1, hydroxide's minus 1, so that formula is fine. Sodium's plus 1 and nitrate's minus 1, so that's fine, but aluminum is plus 3 and hydroxide's minus 1. Notice that I need 3 hydroxides. So I had to put parentheses and a 3 outside the parentheses. So now we've done our formulas correctly. So step 1 was write the symbols, step 2 is write the formulas, step 3 is balance it using coefficients. Now remember, coefficients are numbers in front. They have to be in front of the completely in front of the compound. They can't be in the middle. So if I look at the first thing I've got 1 atom of aluminum and 1 atom of aluminum, so that's good. I've got 3 NO3s. On this side, how many NO3s are there? Hopefully you're thinking 1, because that 3 is part of the nitrate. It's part of the identity. So it's like you write it down, you forget about it because it's part of nitrate. All right, so on this side there are 3 nitrates. On this side there's only 1. So I have to put a 3 in front to make 3 nitrates. There is a side effect. That gives me 3 sodium atoms. So over here I'm going to need to put a 3 in front of the, in front of the NaOH, I'm going to put a 3. If I can get my little pen to work correctly. There we go. And that gave me now 3 OHs. See right there, right there, I have 3 OHs. So on this side, I'm not sure how I erased that, but there were supposed to be 3 OHs in our formula that we had already written a few minutes ago. So 3 plus 3 minus 1, so I needed 3 down here. So now back over here, you see 3 OHs because I put the... Well, I'm erasing things as I go. Sorry about the technology glitches. Someday I'm going to have to learn how to really use this thing. All right, so anyway, that's supposed to be AlOH 3 times, and that 3 matches that 3, and I'm going to let that go because we've done it in class. I'm going to assume that I'm not confusing you too much. All right, the last one. The symbols are aluminum plus iodine. Iodine is one of the Brinkelhoffs. You remember Brinkelhoffs? They occur in pairs when they're by themselves, and since iodine is not with anything else here, it's in a pair. Yields as an arrow, aluminum, and iodide. Okay, over here they're in a compound, so we're going to have charges here. The charges are 0, so you don't have to worry about the charge. But on this side, aluminum is plus 3, and iodine is minus 1. So I'm going to need 3 iodines over here to match that. So now we've done step 1 and step 2. Remember step 1, write the symbols right there. Step 2, write the formulas using charges and subscripts. Number 3, you're going to balance it using coefficients. Okay, so I've got 3 iodines here. I've got 2 on this side. I need a common multiple, 6. So I'm going to put a 3 here. I'm going to put a 2 here because 3 times 2 makes 6 iodines, and 2 times 3 makes 6 iodines. Remember that the coefficients have to go in front of the whole formula, so they're going to always have a side effect, almost always. So the side effect here was making 2 aluminum, so you have to compensate for that over here by putting a 2 in. And that was finished. Now the last one, calcium nitrate. So you're going to write your symbols down. Symbols. What are we writing? Symbols. Ca, NO3, plus sodium phosphate right here. So symbols, Na, PO4. Be sure you notice that there are 3 phosphates on the bottom of your periodic table. There's a hydrogen phosphate and a dihydrogen phosphate and a plain phosphate, and this is the plain phosphate. So yields as an arrow, sodium nitrate, they just changed partners again, like in our lab, plus calcium phosphate. Okay, now looking back, I'm going to work backwards because I'm scrunched up here. I'm just going to go ahead and do this one. That's plus 2 minus 3. So if that's going to have a 3, and that's going to have a 2 to make that formula correct. Sodium and nitrate. Sodium is plus 1. Nitrate's minus 1, so that formula is fine. This is plus 1. That's minus 3, so that formula is not fine. You're going to need to put a 3 in there. This is plus 2, and that's minus 1. And once again, I'm finding these charges on the periodic table. So you're going to have a 2 down there. Now we have the formulas correct. Third step, balance using coefficients. All right, so in this one, First thing you might look at is the nitrate. It's got 2 NO3s. On this side, there's only 1 NO3. So you might put a 2 there. If you do that, that gives you 2 NAs over here as a side effect. On this side, you've got 3. So you can see that 2 and 3 create a problem. So you may have to go higher than 2 and 3, than 2 over here, I mean. So you're looking for a common multiple of 2 and 3, which of course is 6. So we're going to put a 6 here instead. That gives us 6 NAs. So over here, we're going to need to put a 2. 2 times 3 gives you 6 NAs. That also gives us 2 of these phosphates, but look, we had 2 phosphates. So the only thing that's left to deal with is our calciums, I guess, and our nitrates. So we've got 3 calciums here. This side is only 1, so if I put a 3 there, that gives me 3 calciums. But then the side effect of that is it gives me 6 nitrates, because 3 times 2. But over here, we had 6 times this 1 nitrate. Remember that the NO3 is part of the 3, I mean, is part of the NO3. So there are not 3 nitrates in this formula. There's only 1. So when I multiply it by 6, I now have 6 nitrates, which matches the 6 nitrates over here that I used to have before I erased that somehow. Okay, so there's 3 here we put in a minute ago because of the 3 calciums going back over here. So we had that 3 there. 3 times 2 made 6 nitrates. Over here we've got 6 nitrates, so I'm finished.